Now let's look at upper and lower sums. Suppose I have a function f that's defined on a plane and it's non-negative. And suppose I divide this into partitions. I divide a and b up so that the first partition is a plus 0 times my delta x, where this is delta x. Oops, made that too small. And a plus 0 delta x is less than a plus 1 delta x, which is less than a plus 2 delta x, and so on, until this is less than a plus n delta x. Now, look at how I've defined this. I'm going to make this term right here a, or x, and I is 0. This term right here is a sub, or excuse me, x sub 1. This term is x sub 2, and so on, until this last term is x sub n, and that is equal to b. And you remember I've defined delta x is b minus a over n. Now, basically what I've done is I have defined each interval. Now, you remember if I draw a representative rectangle, delta x, at some c sub I, the extreme value theorem tells me that there must be a max and min on this interval. It does not have to be in an endpoint. So if I find the minimum area of this rectangle, that minimum area is going to be the f sub little m sub I, or the minimum height, times delta x, while the maximum area of this rectangle is f big M sub I times delta x. So this is the area of an inscribed rectangle, and this is the area of a circumscribed rectangle, where we define an inscribed rectangle as lying inside the ith region. Now you see it doesn't have to be at one endpoint. And a circumscribed rectangle lies outside of the region. And the area of the actual region is always somewhere between those two. Now let's talk about the lower sum. If I add up all of the inscribed rectangles, I'm going to call this my lower sum, and this is Sn with a little s. While if I add up all of my upper sums, then I'm going to call this my upper sum, or if I add up all the circumscribed rectangles, that gives me the upper sum. And remember, delta x is b minus a over n. Now let's just look at an example here and see if we can find the upper and lower sums for this particular region. And the region is f of x is x squared, and it's between x is 0 and x is 2. Now, let me do the inscribed first. When I do inscribed, then let me look. I want to use the left endpoint. If I use the left endpoint, then m sub I, it's not writing, is it? M sub I is equal to, what is it? It's going to be 0 plus I minus 1 times 2 over n, where I have had to find delta x, and always find delta x first. I kind of do this in my head, which is not good. B minus a over n. So it's 2 minus 0 over n. So delta x is 2 over n. You go ahead and write it up there. All right, so I have delta x, and that's going to be for both inscribed and circumscribed. So the S sub n, the lower sum, is the sum as I goes from 1 to n of f m sub I delta x. Now, f m sub I is, let's see, my function is x squared, so I'm going to take m sub I, which is 2 times I minus 1 over n, and I'm going to square it. Now, I now need to multiply by delta x, and delta x is 2 over n. It's very important you see where I'm getting these parts. Now I'm going to take the sum as I goes from 1 to n. Let me expand this, and this becomes 8 divided by n cubed times I squared minus 2i plus 1. So I'm going to factor this 8 over n cubed out and then do the sums. I know I squared, the sum as n goes from 1, I goes from 1 to n of n squared is n times n plus 1 times 2n plus 1 all over 6. Then it's going to be minus the sum of I is n plus 1 over 2 plus n. Okay, I'm going to expand this out, and I get 4 over 3 n squared, n cubed, excuse me, I've got an extra cube there, times 2 n squared, excuse me, n cubed. I don't know why I'm having trouble with my cubes here, minus 3n squared plus n. And so I get, for a lower sum, 8 divided by 3 minus 4 over n plus 4 over 3n squared. And this is my lower sum. Now let's look at the upper sum, and I'm going to look at the circumscribed rectangles. For my circumscribed rectangles, the right endpoint is 0 plus I times 2 over n, or 2i over n. So for my right endpoint, big S of n is the sum as I goes from 1 to n of f evaluated at big M delta x. So this is the sum as I goes from 1 to n. Now f evaluated at big M is 2i over n squared, and delta x is 2 over n. So when I expand this out, I get, again, 8 over n cubed times the sum as I goes from 1 to n of I squared. All right, so this is 8 over n cubed times n plus 1, 2n plus 1, all over 6. Put in my brackets there. So I wind up with 8 thirds plus, that should be a positive there. It looks like a negative. It's an equal sign. 8 thirds plus 4 over n plus 4 over 3n squared. Now, this is my upper sum. Now I want you to look. If I take the limit of the lower sum as n goes to infinity, this goes to 8 thirds. If I take the limit of my upper sum as n goes to infinity, it also goes to 8 thirds.